The question says arrange the following set of compounds in order of their decreasing relative reactivity with an electrophile. Keep in mind, electrophile are the species which are electron poor. Okay, they have greater tendency to accept electron. Okay, and you can see in A we have chlorobenzene, 2,4-dinitro-chlorobenzene, and then para-nitrochlorobenzene. You can see in each compound benzene ring is present. Okay, and we have learned, benzene ring easily undergoes electrophilic substitution reaction. Why? Because benzene ring has 6 pi electrons. It is electron rich, and that's why easily it can donate electron density. But you can see the reactivity. You might have learned in the chapter. The reactivity of benzene rings depends on the type of the group present in the benzene ring. Because keep in mind, if we have plus m group या plus I group present in the benzene ring, okay, if plus m group या plus I group are present in the benzene ring, keep in mind these are the electron donating group, okay, and hence they are also known as ring activating group, okay, ring activating group are there. If these groups are present in the benzene ring, they always increase the rate of electrophilic substitution reaction. Always remember, okay, the rate of electrophilic substitution, rate of electrophile attack will be very fast. Because why? Because these groups supply electron density to the benzene ring. Benzene ring already have 6 pi electron, and they further increase some more electron density in the benzene ring. So due to high electron density, electrophile easily can get attracted towards benzene ring. Okay, now it's opposite. We have minus m group, mesomeric effect, or we have minus I group is there. If these groups are there, so they are in general electron pooling group. These are the electron pooling group, hence we can say they are ring deactivating group are there. Deactivating group are there. These are known as ring deactivating group, and hence they decrease the rate of electrophilic substitution reaction. Okay, and then they decrease the rate of electrophile attack on the benzene ring. Okay, remember, very important information we have. Based on this information, we can answer this question. Okay, so first of all we can draw the structure. You can see first we have chlorobenzene. Okay, so first we have chlorobenzene. Okay, we can draw the, otherwise let me remove this information. We learn positive mesomeric effect and positive inductive effect acting as a ring activating group, and minus m and minus I acting as a ring deactivating group. Okay, in this case rate of electrophilic substitution reaction will be increasing. In this case it will be decreasing. Okay, now first we have, let's say, chlorobenzene. Let me draw the structure. We have chlorobenzene is there, benzene ring, and we attach Cl is there. We have Cl. Okay, next we have 2,4-dinitrochlorobenzene. Next we have 2,4-dinitrochlorobenzene. This is chlorobenzene in that second position, and this is fourth position. 1, 2, 3, 4. So this is NO2 group is there. NO2. It is NO2 is there, and it is also NO2 is there. NO2. Okay. Next we have para-nitrochlorobenzene there. So we have chlorobenzene, and in the para position we attach NO2 group is there. NO2. So first of all we identify the type of group attached to the benzene ring. Okay, so keep in mind this Cl is having lone pairs. Okay, so they can supply electron density. So they are, we can say, they are acting as a plus m group, and they are donating electron density to the benzene ring. Hence their tendency to donate electron density is very high. Hence they are very becoming further electron rich, and easily they can have reaction with electrophile. Okay, but if you look at here, this NO2 acting as a minus m group is there. Here also we have NO2, it is acting as a minus m group is there. So as the minus m group increases, keep in mind, so rate of electrophile attack decreases. Very interesting part. As the number of minus M group increases, you can see rate of electrophile decreases because minus M group start pulling electron density. They are pulling electron density. They are pulling electron density. They are pulling electron density. So if they are electron rich, when they are pulling electron density, so their electron density decreases. Hence attraction towards electrophile also decreases. Okay, in this case also you can see pulling of electron density is there. They are donating electron density, but you can see minus M group is pulling electron density. Okay, so in this case there is no electron pulling density, okay, because minus M group is not there. Okay, so we have first, okay, in this case electrophile will attack very easily. Okay, then in this case minus M group is very high in comparison to this one, because only one minus M group, in this case two minus M group is there. Then this is what we have second, and then last we have third one is there, because whatever the electron density is there in the benzene ring, easily these groups will pull the electron density, hence electrophile will not attack. So what is the order we are getting in this case? You can see first we have first chlorobenzene. Okay, in the decreasing order we have to write, and then we have para-nitrochlorobenzene, third is there, and in the last we have 2,4-dinitrochlorobenzene, second one is there. Okay, so in the first one chlorobenzene attack of electrophile is very fast, and least in the second, because in this case minus M group is very high. Okay, move on to the next question, and we are going to apply the same concept. Listen very carefully. Next we have toluene, and chemical formula of toluene we have, it is toluene is nothing but we have methyl benzene. Okay, methyl benzene. So benzene ring is there, and here we have methyl group, it became toluene is the common name. Next we have para-nitro, toluene is there, para-nitro, so we can mention we have toluene is there, and in the para position we can attach NO2 is there. And third one we have, this is what benzene ring is there, para-nitro. Okay, we have two NO2 group are there, two NO2 group. Here also we have NO2 group is there. Okay, para-nitro. Now pay attention very carefully. Identify the type of the group present in the benzene ring. It is electron donating group, acting as a plus I group, and we have learned as the plus I group increases, rate of electrophile also rate of attack of electrophile increases. And in this case this is what minus M group, it is what also minus M group is there, minus M group is there. So in this case rate of electrophile will be, rate of attack of electrophile will be drastically decreasing. Okay, so first we have toluene, and then we have para-nitrotoluene, and in the last compound is there, because in this case minus M group is very high. In this compound rate of electrophile, rate of attack of electrophile will be very high. Okay, then this one and then this one. Okay, so this is the order we are having in the decreasing order. This is the question is asking for decreasing relative reactivity of electrophile over these compounds. If you like this video, please share and subscribe to the channel.